So if I was given a series like 1 over 3 to the n plus 2, and I want to decide the convergence or divergence, what I notice is that it's really close to a geometric series. A geometric series would be a number to a power. And if this plus 2 was not here, that would be a geometric series. So this series is really close to the geometric series. So what I would do to actually decide the convergence or divergence of this series is compare it to the geometric. So I will compare this series to the sum from n equals 1 to infinity of the geometric that it's close to, 1 over 3 to the n. So this series is geometric, and for geometric we look for our common ratio. So our common ratio is whatever is raised to the n power, and this 1 in the numerator could be like a 1 to the n. You could rewrite this as a 1 over 3 to the n. So the absolute value of my common ratio is equal to 1/3. And because that is less than 1, I know that this series converges. And again, for geometric, think about it as a percent or just a fraction. Each time my next number is going to be 1/3 the amount of the one before, so it's decreasing rapidly. It's less than 100% that you're multiplying by. So the next thing I do is I want to actually compare these two. So this one converges. My direct comparison test says that if this one is less than this one, then this one will also converge. If this is greater than that, the test fails. It doesn't say it diverges, it just says that you can't do a direct comparison. So I'm going to write the inequality. I want to know is 1 over 3 to the n plus 2, is it less than the one I'm comparing it to, a 1 over 3 to the n? And if you look at this, you'll see that the denominator of the one on the left is greater, which means the whole fraction is smaller, and that will be true for any n value here. So this series is less than a convergent series, so this series must also converge. So that's what I would write down. I would say the series from n equals 1 to infinity of 1 over 3 to the n plus 2 converges by the direct comparison test. Looking at this series, I would say this is really close to a p-series. And what I'm looking at is what's the dominant term in the denominator here, and it's the square root of an n. So this is n to a power, n to the 1/2. So this is close to that, so that's what I'm going to compare it to. Compare to the sum from n equals 4 to infinity, and if you look at the 4, the square root of 4 is 2, 2 minus 1 is 1, so what they're doing by making this n start at 4 is keeping this positive, and you don't have to worry about any undefined terms from square root of a negative. So we have the sum from n equals 4 to infinity of 1 over the square root of n. For this, I know this is a p-series, and 1 over the square root of n is the same thing as 1 over n to the 1/2. So p equals 1/2, which is less than 1, which means that this series actually diverges by the p-series test. All of our divergence tests say greater than 1 diverges except for the p-series. All of the ones involving 1 and, well, 1. Okay, so this one diverges. If this one is greater than something that diverges, this must also diverge, because if this one diverges, we're saying that when we actually add this up, the sum is headed towards infinity. But this one is bigger. If it's bigger, it also has to head towards infinity. So I would want to check, is 1 over the square root of n minus 1 greater than 1 over the square root of n? So I look at it, and this denominator is less by 1, which makes this whole fraction bigger. So this is a true inequality. That works. So I know that this series, the series from n equals 4 to infinity of 1 over the square root of n minus 1 diverges by the direct comparison test. The next test that the videos are going to cover is the limit comparison test, and you will use it if this inequality statement isn't true or if you can't tell. So imagine if you're adding and subtracting terms in, so you're not sure if it's greater than or less than, or if it turns out, well, this one is less than that one, so how do I know? And that doesn't mean that you've wasted your time checking with this. You will use a comparison test, so you will still have to decide what am I comparing it to, figure out the convergence or divergence of that, but you'll have a different method for actually checking to see if it does converge or diverge for that series. So that's the limit comparison test, which are the next videos.